calculators, by the way, so bust those out. We need to do a little bit of maintenance on the calculators before we get started. Yeah. So up at the top there, you'll see a little button that says Mode. Hit that Mode button. First couple lines, you should already be on normal. You should be on float. That's fine. The third line, it says radians and degrees. You want to be on degrees, so move it over to degrees and hit enter. The rest of it is all inconsequential. As long as it's normal, float, and degrees, you should be okay. Now, if you want a good prank to pull on your friends, this is a good one. Right before the quiz, like when they get up to sharpen their pencil, just reach over and hit the mode button and put it back in radians and go back to the home screen.
That's satanic.
That's a great trick, because you know what? They get every answer wrong.
That's probably something Emmett would do.
No, I'm nice. I wouldn't do that to anyone.
You're nice? All right. When did that start?
I'm so nice. Everyone.
Okay. All right, so there is no reason for you to ever be in radians in this class. We don't do radians. That'll change as you go on with math. Obviously, depending on the topic that you're talking about, you'd be in the different modes. So for instance, my calculus students, their calculators are always in radians because we use a different system, but you should be in degrees. Okay? It might not be a bad idea before assessments to hit the mode button to make sure nobody like Emmett has messed with your calculator. Okay, we good? Beautiful. Set those aside. Let's get started. We're just doing Pythagorean Theorem today.
Nice.
We've done Pythagorean Theorem. This should be a cakewalk, right?
No, probably not.
There it is, Pythagorean Theorem.
Me too.
Technically speaking, the sentence is the Pythagorean Theorem, but if you stop some person on the street and you say, hey, what's a Pythagorean Theorem? If they have any idea what you're talking about, they're probably going to tell you a squared plus b squared equals c squared. What do you need to know about this? What's that? What's that? C is the hypotenuse, correct. Most common mistake that people make with Pythagorean Theorem is they take whatever two numbers they're given, they put one in for A, they put one in for B, and they solve for C. You can't do that. A and B are the legs, C is the hypotenuse. You'll be given two of the three. Plug and chug, solve. Any problems? If it says exact, your answer should be in radical form. If it says approximate, we're going to round to 2 decimal places. We good? Okay, find x. Notice it says exact and approximate. Whoa.
Oh,
For some reason, Emma just growled. Real quick, stop what you're doing, look at the picture. Is x going to be bigger or smaller than 15?
Bigger.
Bigger, good. Oh, you got that? Okay, good, go. I don't know if that's right, but we'll go with it. It's ready to go. It's red if that's okay. If you don't like red, you got to click on one of the colors. Angle the pen a little bit more, it's easier. There you go. Agree or disagree?
Agree.
Agree. Well done, Morgan. Let's give it up. Golf clap.
Wait, I got 16.1.
Yes.
Uh-oh.
I think it's just
What's the square root of 261?
It's like 30.
Oh, girl.
I just said
16.
16.16. Copied it wrong off her calculator. 3 squared root of 29 is good though, right?
Yeah.
Yeah, good. Notice she simplified her radical so that it's not just a square root of 261. You gotta find something that goes into that. That is the perfect square. Any problems? Beautiful. All right, click on this guy. Click on this guy. Whoosh. Solve for x. Will x be bigger or smaller than 11?
Smaller.
Smaller. Will it be bigger or smaller than 9?
Bigger.
I don't know. Doesn't matter. Well, it's gonna be less than 11. Well, and the right answer. Also, for future reference, remember I can't grade your calculator, so you want to include as much as possible when you're showing work. Show me what you plugged in for A, show me what you plugged in for B, show me what you plugged in for C when you're solving. This is tight. All right, Anna Maria, what do you got?
X equals 6.32 and x equals 2 square roots of 10.
How'd you do?
Good.
Nicely done, golf clap. Okay, we've done that before, no big deal. Now we need to talk about another example. I'll let you read that, because I find it insulting when people read things to me, so therefore I'm not going to insult you by reading it to you. I would suggest you draw a picture first, then solve for x, because it says make a sketch. It doesn't have to be 100% accurate. I mean, you don't need, it doesn't have to be picture quality. We are going to make one assumption for this problem. What is the assumption? Yeah, the building is perpendicular to the ground. It's not on a hill. It's not the Leaning Tower of Pisa. I understand. Let me know if you need help with the big words. Gesundheit. Excellent ladders as I walk around the room. Then again, some of you didn't even bother drawing the ladders. Bad attitudes. Okay, so this is a quote-unquote real-world problem. Do we care about the exact answer? If you're working on a construction site and you're setting up a ladder, are you going to care about the fact that the ladder can reach the square root of 375 feet up the wall? No, so we probably just want an approximate answer, which is what? 19.4. I rounded to tenths, probably should have gone to hundreds. Anybody have a problem with that? Okay, the ladder is 20 feet, therefore that's the hypotenuse. The bottom would be 5, because that's 1/4 of 20. Solve for the other leg. X squared plus 5 squared equals 20 squared. You get square root of 375, which is 19.37 or 19.4. We good? Awesome. Anybody ever seen these before? Okay, so in the trying to broaden your horizons and make sure that you are aware of cultural significance, these are two GIFs that you can find on the internet, frequently referred to as Dancing Spider-Man. And then on the left is Dancing Spider-Man with a couple other people. One is Voltron, and I don't know who the others two are. The significance of these GIFs is that they will appear to dance to any song that you put on.
Can I try it?
Sure, you got a song? All right, get a song. While she's doing that, let's talk about the converse of the Pythagorean Theorem. Converse of the Pythagorean Theorem goes backwards, because we know what a converse is. The Pythagorean Theorem says, if you have a right triangle, then this stuff is true. The converse says, if this stuff is true, you have a right angle. So you're going to be testing whether or not these triangles end up being right angles. Common mistake that people make is they put right angles in where they're not supposed to be, or they don't bother checking to see if we're starting with a right triangle. Make sure it's class appropriate, no swear words. Do you have any music that doesn't involve swear words?
Well, yeah, I have a request from Grace, but
What does Grace want to hear?
what do you mean by this?
Okay.
Just go on
Yeah.
YouTube.
Are you a big Justin Bieber fan, Grace?
Yep.
All right.
I know it, please.
What do they call Justin Bieber fans?
Believers.
What are they?
I know.
Believers.
The 23rd.
See,
Is that a good?
There's an ad.
why is it?
I'm sorry?
There's an ad.
23rd. Is that Friday?
They might even dance to the app.
Spider-Man is.
Yeah, turn it up. Is that as loud as it goes?
No, I have like speakers
Oh,
on
is this in here?
Go stand next to the
Sorry.
screen, Vanessa.
There's like talk in the beginning. Is it like a lot of it? Yeah.
What song is this? Dancing kind of fast.
Told you. Can't stand it. We turn it off. I can't stand it anymore.
It's a really slow song.
All right. Which, if any,
I don't have it.
are right triangles?
Okay.
All of them.
You are.
So the question is, since we don't have a right angle marking in there, how do you know which one is the hypotenuse?
The
Short
longest.
The longest. Don't rely on the picture.
It's the biggest.
Some jerk of yours might put that 17 down on one of the legs. See if you're paying attention. Blue, yes or no?
Yes.
Yeah, because 8 squared plus 15 squared is in fact 17 squared. Green?
No.
No, because 30 squared plus 40 squared is not 45 squared. And purple?
Yes.
Yep, because 0.7 squared plus 2.4 squared equals 2.5 squared. This should not be incredibly difficult, and as I mentioned, the only snafu that comes in here is when you put the lengths in the wrong positions. Oh, by the way, is the green one even a triangle?
No. No.
No.
No, because 30,
What determines whether or not that's a triangle?
the short sides are.
Subash,
The short side should be greater than the longer side.
and is it?
No.
Yeah.
Oh, yeah, they are.
30 plus 40.
40
plus 30
Is 70 greater than 45?
Oh, my bad.
Yeah, how about the blue one?
Yes.
Yeah.
Yep, and the purple one?
Yes.
Okay, so all three of them are triangles, no problem.
I was thinking.
Now, the next question is then, if they're not, well, first of all, we know they're all triangles. We know that the green one is not a triangle, sorry, it's not a triangle. It's not a right triangle. The question is, what kind of triangle is it? Is it acute or is it obtuse? Yes, it is scalene. You're right, it is scalene. But is it acute or obtuse? Guesses?
Acute.
Acute, because it looks acute?
Yeah.
All right. Let's skip that a second and do this. Okay. This is now called the Pythagorean Theorem inequality. It allows us to determine what kind of triangle it is based on the angles. One of those is the acute, one of those is the obtuse. Which is which?
One is acute and two is obtuse.
Why? Just because you're guessing and you had a 50-50 chance?
No.
Okay, then why?
Because, I don't know.
So you guessed.
Yeah.
Alright, good. I know how to eventually. This can be tricky remembering which is which. So I'll show you how I do it. If this helps you, great. If it doesn't, then you can just memorize it, but I'm not a big fan of memorizing. The way I do it is I always go back to an equilateral triangle. So let's take an equilateral triangle. What kind of triangle? Acute or obtuse? Acute. So let's make all three sides 4. You can make it whatever you want. You can do 6, 4, a billion, I don't care. Which one of these is over there? 1 or 2? Which one's A, which one's B, which one's C? It doesn't matter, they're all 4s. So is 4 squared plus 4 squared greater than or less than 4 squared? Greater than. So therefore 1 is acute. Good. That's how I remember it. If you have some other method, great, roll with it. Okay, which means that's acute, and the other one is obtuse. In the past, way back in chapter 1 or 2, when we were talking about triangles, we would classify triangles by their side length, which was scalene, isosceles, equilateral, and sometimes by the angles, acute, obtuse, and right. We ran into some instances where we couldn't talk about whether it was acute, obtuse, or right. That problem is now solved. You could use those theorems, the Pythagorean Theorem inequalities, to figure out whether the triangle is acute or obtuse. So if we go back, what's the green one? It is acute, because 30 squared plus 40 squared is greater than 45 squared. All right, we good on that? This slide about Pythagorean theorems is not mandatory by any stretch of the imagination. In fact, if I click off this slide and you forget about it, it's not the end of the world. Pythagorean triples is just a way of saving time. It's a nice simple theorem. That's Pythagoras, by the way. Pythagoras realized that there were certain triangles that were right triangles that had nice pretty sides. And you've run into these already. In fact, we've had some in the slideshow already. A 3, 4, 5 will always make a right triangle, because 3 squared plus 4 squared is 5 squared. There is an example of 5 of them. It's just a time-saving device. The cool thing about it, though, is that you can take any one of those Pythagorean triples and multiply them or divide them all by the same number, and you get another Pythagorean triple. So for instance, a 6, 8, 10 is a Pythagorean theorem. A 10, 24, 26 is a Pythagorean triple. And in fact, we saw one of those back here. Obviously, the blue is a Pythagorean triple. It's one of the ones listed, 8, 15, 17. But notice the purple one. That's a 7, 24, 25 that's been divided by 10. So again, if you start, when you're working through the homework, if you start to see these Pythagorean triples pop up, you might get a feel for which ones make Pythagorean triples. If you don't, it's not the end of the world. You just go back to Pythagorean theorem. A squared plus b squared equals c squared. By far the most common is 3, 4, 5. They pretty much go in order of commonality. Is that a word?
I don't know.
It is now.
It is now.
We did that already. We're done. Okay. Any problems, questions? Pretty much one new thing in the slideshow, and that is determining whether the triangles are acute or obtuse.
3.